Types of solids. We have two types. One is crystalline, and one is amorphous. A meaning, again, without, so without shape. Your crystalline solid will have a 3D repeating pattern to it. That's why you see a crystal. Our glass used in a window is not crystalline, or it'd be, you'd see this crazy rainbow reflection of light coming through your window, and you wouldn't be able to see out clearly through that. Your amorphous is without shape. This is a non-crystalline solid in which the particles are in random arrangement. Generally form quickly so that atoms do not have time to align with themselves in a regular pattern. And we'll find this with quartz and with glass can be mixed with other things to actually make it stronger, which is important, especially for the windshield of your vehicle. Crystalline structure. Crystalline structure is a 3D geometric structure, The lattice points, key point here, lattice points can be atoms, molecules, or ions that occupy a position that define the actual geometry of the crystal. So make sure you circle that. A crystal, 3D geometric structure crystal, it all starts with a basic unit cell, and this unit cell repeats itself over and over and over again. There are 7 types of unit cells. Just know the number 7. Let me go into the types of crystalline solid. The first is that of ionic. Its lattice points are the ions. They have strong attractive forces. It's an ion-ion intermolecular force. Therefore, they generally have a high melting point. They, as solids, do not conduct electricity. However, in a liquid state or aqueous state, they will conduct electricity. Covalent, the lattice points are your atoms. Diamond and graphite are example of here. And we can see diamond and graphite next to this. In a diamond, each of the carbon is a sp3. It's a tetrahedral shape, so each of the carbons will have four other carbons around it, so it's an sp3. My graphite is an sp2. Therefore, the carbon diamond, being an sp3, has 4 sigma bonds, but the sp2 has 3 sigma bonds and 1 pi. And again, with this one, the graphite will keep a 3D, will keep a trigonal planar in a shape, and actually each of those levels actually shaves off when you're using your pencil. Now, because the p orbital electrons are free to move along the layer of the graphite is a good conductor of electricity. Your diamonds are not. Quartz, your SiO2, is also a covalent structure or crystal. At the lattice points are silicon and oxygen atoms. The third type is your molecular. The lattice points here are your molecules. These are relatively weak intermolecular forces. Examples there of ice, your water molecules frozen together. Molecular crystals are relatively easy to break apart due to the weak intermolecular forces holding them together. Therefore, their melting points are generally low. The fourth one is that of metallic, and these lattice points are your metal atoms, and these are generally your difference between if you look at covalent or non-metal atoms, where your metallic are actually metal atoms. The metallic is generally are solids and very dense. The bonding electrons are delocalized, and means again they have the ability to be able to move. They have the ability to flow. We create a sea of electrons. Therefore, they become good conductors of electricity. Types of crystals is a chart from your book, again 11.4. Make sure you look at this chart and know this chart. This kind of summarizes everything we just talked about. Great multiple choice questions come from this. And know your examples as well. And right here, molecular, there we have our dispersion forces, dipole, hydrogen bond. These are your van der Waals forces.